Hi, hello to everyone. This is Dr. Satheesh Kumar. I'm working as the Associate Professor in the Department of Information Technology at the Institute of Aeronautical Engineering, Hyderabad. So, in this session, just I'm going to present the best search algorithm in artificial intelligence. So, previous session, just you can see that what are the various algorithms are going to present to solve some certain problems using the artificial intelligence machines. Okay, so that is we comes to know that is two types of algorithms: informed search and uninformed search. So today's session onwards, just we are going to start the informed search. So it's one of the major techniques, a major method to solve some particular problem. If you are using some algorithm, means the informed search in artificial intelligence. So in that, the first just we are going to see about the best first search algorithm in artificial intelligence system. Okay, so in that. The overview of today's session is the definition of the BFS. That is a breadth first search. What is a breadth first search? How it will come? How we are going to use some specific algorithm to solve some particular problem in artificial intelligence. Okay, so the next one is algorithm. Okay, so what specific algorithm we are going to do solve some critical problem step by step. Okay, so each and every step how we are going to do, how we are going to solve the particular problem, how we are going to reach the goal node with the different steps, right? So that one we are going to see in these algorithms. Okay, the last one is example. Okay, so if you having some critical problem, okay, how we are going to solve, how we are going to reach the particular goal node with the proper steps. Okay, that we will see in the given example. Okay, so let us start. The first is what is the BFS in artificial intelligence. So already we comes to know the different methods, the different algorithms we have to solve some particular problems, right? So that is the uninformed search, informed search. Okay, so this one is it will come under the informed search, right? So this is the first type of the first algorithm to solve a particular problem in artificial intelligence machines is BFS. Okay, so this one is also called as some greedy method. Okay, so this one is also called as a greedy method or BFS. Okay, breadth first search algorithm in artificial intelligence machines. Okay, so the first point is it is also the greedy search algorithm. Okay, and then it is always select a path which appear best at the moment. Okay, so it will select. Okay, so it will produce. Okay, at most the optimal a solution for the given problem. Okay, so for that it will select the promise nodes. Okay, so it will visit. For example, if you are having one tree, A, B, C, D, E, F, G. So this one is a tree. So from this root node, from the social node, it will visit on each and every nodes. Okay, so from this A to that particular, it will come to B. Then next it will come to C. It will visit the both A, B, and C. Okay, so here you go. Just the F is the goal node. Okay, so F is the goal node means so it will visit the premise node and it will select the path in the best way. Okay, so A to C, C to F, like this it will select the path to reach the goal node. Okay, from the root node to goal node. That is the initial node to goal node. Okay, so it is a combined of a BFS and a DFS. Okay, so only just we are telling that it is a greedy method. It is a greedy search. Okay. So it is a combined of a BFS and DFS, breadth first search and depth first search. Okay, it will come under the combine of both BFS and DFS. So it is used as a heuristic function. Just already we know that in the previous session itself I said what is the heuristic function, how we are going to calculate the heuristic function of given to the given problem with the given different algorithms, right? So here the h of n is equal less than or equal to h star of n, and such the, if you want to search the particular node in the given the graph, if you are using that given node and given a heuristic function means this one. Okay, so this is a formula. Okay, so here h of n is a heuristic cost. Okay, each and every node we have, for example a to b means here I have some value, that is a cost of a and a b, right? So that's the heuristic cost. Next is h star of n means estimated cost. Now we are going to calculate the distance of the particular node. Okay, if you want to go to that a to f, we need to find the shortest path. Okay, if you want to, if need to find the shortest path, you need some distance of the particular node and the cost of the particular node. So that one is the some estimated cost of the particular node, h star of n. Okay, clear. So the greedy first search algorithm, so simply they will tell that, and the best first search algorithm is always the greedy best first search algorithm is implemented by priority queue method. Okay, why we are saying this is a priority queue means it will visit promised nodes. It will select the path as a promised node. So it will select the best node while you are reaching to the goal node. So it will give the priority to the best node. Okay, so that is technique is always called as the priority queue method, right? So this one is my best first search algorithm and definition and the concept of the how we are going to calculate we are going to reach the goal node with using the heuristic function, right? The next one is algorithm. Okay, simply just I'm going to tell that what is the algorithm, what is the working steps of to solve a given problem using the best first search algorithm. Alright, so the first one, the first step, right? So what is the first step? Just everyone know that it is a step by step the process, right? Just we are going to take some the each and every move, the best to move. Just we are going to follow each and follow one steps, right? So that we are going to tell that the first is place the starting node into the open list. Okay, here just we are going to use that open and the close. Okay, so here just we are going to use open and close nodes. Here just we are going to use open and close concepts to getting the select the path between the given nodes. Okay, so if open list is empty, then so what is the second step? Just we are going to use if we are going to select the first node. Okay, then we are going to use the open. For example, the first node root node is A, so that A going to be put on the open. Okay, so close means if you are completing that particular node, so just we are going to write here as the close the particular node. That if it is so that node, that root node is visited, and we are going to select the another source node. Okay, to reach the next best node. Okay, so if the open that way, just we are going to follow to solve a problem using the best first search algorithm. Okay, here if the open list is empty, stop and return failure. Okay, so the open list should not be empty, right? While we are going to writing that solve a problem, that open list should not be empty. If it is so, that system, that method is going to be stop, and that method we are going to tell that it is a failure 1. Okay, so that is a step 2. The next step 2, 3 is remove the node n from the open list which was lowest value of h of n. Okay, so we are going to take the distance of the particular node, or otherwise this is the cost of the particular node. That is a heuristic function. So from the setup, we are going to compare the next child node, which one having the least value, that we are going to select. Okay, so if it is so, the remaining node we have to remove from the open list. Okay, for A, B is there on the open node. Okay, so here A having the value of 2, B having value of 3. Right, now we are going to select the next root node as here A. Okay, from so here B we are going to remove. So B just we are going to remove. Okay, that is it, step 3. Right. So what is the step 4 means? Expand the node N. Okay. So after visiting that selecting that status value as a node A. Okay. Next we are going to select the next node. Okay. So that only expand the node and generate the success of the node N. Okay. Here the A is here, already we selected A. So A is a successor node. Okay. That the best node. Okay. Best path to reach the next node. So the next one is step 5. Okay, check each successor of node N. Check each successor of node N and find whether the node is goal node or not. Okay, so same like this, just we are going to select one by one. Okay, so one by one nodes. Okay, best nodes. If you are reaching that best node, so that if you are selecting that particular best node, that one you have to ensure that it is a goal node or not. Okay, then after otherwise, just we have to move to next, finding the next best node. Okay, so if any successor node is goal node, then return success and terminate the search. Okay, if you are reaching that goal node, after that we no need to. What is our goal? Just we have to reach the goal node. After reach the goal node, we no need to do further anything. Okay, so we have to return and terminate that particular process. Okay, the next one is search tree. For each successor node, algorithm check evaluation function. Okay, already we said I have the heuristic function, right? We will calculate the cost. So that one we have to check after reaching the this is a successor node. Okay, then check the node has been either open or closed list. Okay, so particular goal node should be in the closed list only. Okay, it's not should be in the open list. Open list means it is a open for the do the next process. If it's a closed means this is the goal node. We are going to reach the goal node to source node to the destination node. Okay, so closed list. If the node A has not been both the list, then add it to open list. Okay, if it is a closed list is not that particular goal node means again if the node is available, just we are going to add into the open list to start the search again. Okay, so the return to step 2. Again, just we are going to return the step 2. Right? If it is not reach the goal node, again we have to follow from the step 2 onwards. So this is a specific algorithm to find the or to reach the goal node. The next one, just we will see the one best example to under betterment of the understanding the how to the best algorithm is working the given problem. Right? Then I will write one tree, construct one tree here. A to B, B, C, D, E, F, H, I, J. So this one is one tree. Now just I'm going to write the value of each and every node. Okay, so node. Okay, here the value of the heuristic function of each and every node. Okay, so here S, A, B, C, D, E, F, H, I, J. So just based on this tree, just I'm writing all the nodes here. So from here, just I'm writing some value of each and every nodes. Okay, yes, A, B, 4, 7, 3, 8, 2, 4, 9, 0. 2490. So like this, just I'm going to assign the heuristic function value, that is the cost of the particular and nodes. Okay, so this one is here, this is here given the tree. So from the given tree, this I'm going to consider that given the nodes. So for that nodes, yes, I'm going to assign some heuristic function value, that is a cost of the particular node. Okay, so just I'm assigning here. So after that, what is the first step? Just we are going to initialize. Initialization. Okay, the first step is just we are going to initialization. The next step is just we are going to take. So what is the first step? Here just we are going to place the starting node into the open list. Okay, so here first, what is the first initialization? The first initialization, the root node. S is the root node. Just now we are going to select the source node or selected node. Okay, selected node is yes. Okay, that is an initialization. Okay, the S is the initialization value. So that here we are going to assign the 13. Okay, what is the heuristic function? That what is the cost of your node is 13. Okay, so that I am going to assign here. So next one is just initial step is just open list. Okay, so in the list that I'm going to insert. So what are the what are the select best nodes are present under this root node? Okay, so what are the root node is there for S? Okay, so what are the child node for S, A and B? So here just I'm going to write A comma A comma B. Okay, so open list. Then close list. Yes. Okay, so how we are going to write the close list? Yes, already just visited list is the root selected node is yes. Okay, so that should be, see here, that should be written over the close list. Okay, so the next one, the next step is, so the next step is just we are going to again we are going to write the open list. Okay, so before that just we are going to write the assign the value of each and every node A and B. Okay, so what is the value of A and B here? What is the value of A? 12. Okay, so what is the value of B? 4. Right, so this one is value the cost of the each and every node. Okay, so the next one is now just what is the third step? Remove the node n. Okay, so remove the node n from the open list which has lowest value of our cost. Okay, so from here just we are going to compare. Okay, here is 12, here is the cost of your node is 4. So which one is lowest cost? B, that is 4. Node B is the lowest cost, right? So now we are going to remove the this B from, that is node B from your open access open list. Then we have to add into the close list. Okay, so now it is selected. Okay, the 4 will be is considered as a lowest cost, lowest value from your selected node. Okay, now is a B is a selected. Okay, so it is closed list. Okay, just we are going to remove from the open list, that B should be added into the closed list. Okay, so the next step is again just we are going to consider the closed list. Okay, now is selected node is a B. Okay, so from B, how many nodes are for B? Now it is considered as a source node, that is a root node. Okay, so from B, how many nodes are there? How many child node are there? E and F. Okay, now we are going to add E and F into the open list. So just we have to write as it is, right? So now just we are going to next we are going to assign the value of E and F from your table. So what is the value of E? 8. Okay, so what is the value of F? 2, right? Clear? So now just again we are going to follow the steps 3, right? We have to compare the value. So we are going to select the list value. So from the open list, the list value we are going to remove. Okay, so here which one is a root list value? 2, right? So this one is a 2, right? So now again open. Just root 2 means root f. Okay, node f. So now f we are going to remove from your open list. Just we are going to add into the closed list. E, A, then close of S comma B, F, right? So this is like this. Just we are going to remove from your open list. We are going to include into the closed list. Okay, so now F is selected. F is in the closed list. So F node F. Just we are going to select as a root node. Okay. So what is the third step? Open. Already E is there, A is there. Then from root node is F. Okay, now what is the child node of F? I and G. Okay, I and G. Then close node is same. Okay, then next open. Okay, now we are going to consider, just we are going to consider that heuristic function value, that is cost of each and every node. I, what is the I value? 9. So what is the G value? 0, right? So here now we are going to compare the both the node values. Okay, distance of your both the nodes. Okay, I comma G. So which one is a least? 0 is a least. So now we are going to take a G as a root node. Okay, so now so that we are going to remove the G from your open list. We are going to include in the into the closed list. Okay, E, A, I. Then close S comma B comma F comma G, right? So now just we are traveled. Okay, we are in the node of G. Okay, here the goal node is G, right? So now in the final stage of to selecting the goal node. Okay, so G is the goal node. So just we have reached. After that there is no nodes. Okay, so what is the path from source node to goal node? So S, B, F, G. Okay, so this one is a path from to shortest path. Okay, this is not a path. The best steps, best nodes, best path. Okay, to reach the goal node from your source node. So here A2. Sorry, how we are going to travel here. So A2 B, B2 F, F2 G. Okay, so sorry, S2 B, B2 F, F2 G. S2 B, B2 F, F2 G. So if you want to calculate the distance of each and every node, that we have to calculate. A to B 4 plus 2 plus 0. Okay, so 8 is 2 like this. Also 6. Okay, so the distance of to reach the goal node is 6. Okay, like this, just we are to reach the goal node for given problem using the first search algorithm. Right. So this is the path. Okay, so A to S to G. Okay, so this way just we are going to find the path between the given the problem. Right. So clear, right? So I hope everyone just it is clear this one. Okay. So for example, just if the best first search algorithm in your data structure, just we have used so many ways to solve a problem or to finding the distance or finding the path. Alright, if you are given the graph, okay, it is having some directed graph and undirected graph. From the undirected graph or directed graph, just we are going to find the distance of each and every nodes and the path between the path between the given nodes. Okay, so if you want to A to E, so which one is the shortest path? Okay, just we are going to use some algorithms, so distrust algorithm, tracement problem algorithm. Just so many techniques are there to find the path and distance of each and every nodes. Okay, so here in the artificial intelligence, just we are going to find the path or distance of each and every node like this. Okay, just if you are using the open and close list to each and every step, just you can easily find the best path to reach the goal node. Okay, so here just we have seen the various steps to reach the goal node. Okay, next just we are trying to complete find the time complexity. Okay, time complexity of this node is order of b power m. Okay, so the b is the function of our heuristic, and the m is the maximum profit. Okay, maximum value of your given node. Okay, then next the space complexity is the same order of b power m. Okay, so the time complexity and space complexity is both the same because we are going to find best path and distance from the given problem. Right. So if it is so in this method, okay. So now finally, just we are going to find the given problem is completed or incompleted. Okay, in example, just we are going to give we have to give some suggestion to for particular algorithm is completed or incompleted. So this one is incompleted one. Okay, so why means just see here in this algorithm, just we are going to what we are exactly we are going to do exactly, just we are going to choose the particular path to reach the goal node. Okay, so here that algorithm, it will not visit each and every node. Okay, so here C is there, D is there, here H is there. Okay, so remaining nodes are there without visiting that one. Just we are going to find the shortest path. So that one is, this algorithm is always called as the incompleted one. Okay, the next one is, so if it is so, it is called as, this solution is called as the optimal solution. Okay, so the time complexity, space complexity is also very low. Okay, so the order of b power m, order of b power n, so it will come under the worst case. Okay, worst case, and it is this, it will not visit all the presented nodes, though it will called as the incompleted one. Okay, this algorithm is always called as the incompleted one. It is so if it is incompleted, so automatically it will come, and also it is saying that it is worst case. So this one is the optimal solution only. Okay, it is not a actual solution. This is an optimal solution only. Okay, so what is the advantages? So it is that time construction is very more efficient to reach the goal node. Okay, so we have to find this path between the source node to goal node very easily to using some best first search algorithm. Right. So the next, these are the some reference books, reference webs. References just I'm going to use to collect all the information. Just if you want to use, just you can refer this one. Just if you have any comment, just post in the comments. Just I try to solve this one. So from the next by the next session, just I will tell you different algorithm in informed search algorithm. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.